Imagine you are standing on the edge of a cliff. Below is an abyss. But it is not just a dark pit. It is an ocean of light. You look at the map of the starry sky and see familiar outlines. Here is our galaxy, the Milky Way, our home, a spiral island shining in the darkness, 100,000 light-years in size. It seems like the limit of greatness. For light to cross it from edge to edge, it takes 100,000 years. This is an unthinkable figure for the human mind. We are grains of sand living on the outskirts of this giant. But now imagine that someone took our Milky Way and compressed it to the size of a small coin. And right next to it, they placed an object that takes up the entire table. No, the entire city. Today, we are setting off on a journey to a monster that makes astronomers feel not just small, but non-existent. We are flying to an object that, according to all laws of physics and common sense, should not have grown to such a size. It is not a black hole and not a quasar. It is a galaxy, but such a galaxy that could swallow our Milky Way without even noticing it, like a whale swallows plankton. Its name is IC 1101, the Queen of Galaxies, a Leviathan sleeping in the center of the Abell 2029 cluster. If you think you know what big numbers are, today your idea of scale will be destroyed. We are used to comparing planets, stars, even distances between them. But when it comes to this object, familiar rulers break. 6 million light-years in diameter. Just think about those words. Light flies for 6 million years from one edge to the other. This is 60 times larger than our galaxy. If we placed this monster in the place of the Milky Way, it would swallow not only us, it would swallow the large and small Magellanic Clouds. It would swallow the Andromeda Galaxy, which is 2.5 million light-years away from us. It would fill all the space that we call the local group, and it would still be cramped. Today, we will learn the terrible truth about how such giants are born. We will find out why this object is called a cannibal galaxy, and how many trillions of stars had to be killed and consumed to build this body. We will look into its heart and see a supermassive black hole that is itself larger than our entire solar system. And most importantly, we will try to understand what awaits this galaxy in the future. Is it dying, or is it already dead? And we are simply looking at its cooling corpse, which continues to shine by inertia? Buckle up. We are leaving the safe haven of the Milky Way and heading into the abyss where real monsters live. But before we get close to it and feel the heat of its trillions of stars, we need to understand the context. We need to understand how we found it in the first place and why for a long time no one understood what they were dealing with. The story of the discovery of this object is a story of how humanity slowly gained sight, realizing the scale of the universe. It all started in the late 18th century. On June 19, 1790, the great astronomer William Herschel pointed his telescope at the constellation Virgo. He was looking for nebulae. At that time, no one knew what galaxies were. People thought that the Milky Way was the entire universe, and the misty spots in the sky were just clouds of gas inside our system. Herschel saw a faint, blurry spot. It wasn't bright. It wasn't beautiful. It was just a dim light in the eyepiece. He recorded its coordinates, assigned a number, and forgot about it. He didn't even suspect that in that second, his eye caught photons that had been flying to Earth for more than 1 billion years. He was looking at the largest object a human had ever seen, but he couldn't realize it. Centuries passed. Our telescopes became bigger. We realized that the universe is not limited to the Milky Way. We learned that those very nebulae are island universes, other galaxies similar to ours. And so, in the 20th century, astronomers looked again at that very spot that Herschel found. It received a catalog name IC1101, and when they measured the distance to it, their breath was taken away. It turned out that this spot is not nearby. It is located at a distance of more than 1 billion light-years from Earth. To give you an idea, most galaxies that we see through amateur telescopes are tens of millions of light-years away. And here, 1 billion. And yet the object was visible quite brightly. This could mean only one thing. The true brightness and true size of this object go beyond anything we had seen before. It was like seeing light from a pocket flashlight, but then finding out that this flashlight is on the moon, and realizing that it is not a flashlight, but a searchlight the size of a city. IC1101 sits in the center of a huge cluster of galaxies called Abell 2029. Imagine a swarm of bees. Thousands of galaxies circle around a common center of gravity. They fly, interact, sometimes collide. But in the very center of this swarm sits the queen, huge, motionless, and dominant. This is our heroine. She is not just part of the cluster. She is its heart. She dominates the entire environment. Her gravity is the law that thousands of other galaxies around her obey. But let's take a closer look at her. What does she look like? If you expect to see a beautiful spiral, like our Milky Way or Andromeda, with graceful arms where new stars are born, where blue and pink nebulae shine, then you are in for a disappointment, or horror. C1101 is an elliptical galaxy. It is a giant, shapeless ball of light. It looks like a bloated golden cloud. It has no clear structure, no arms, no disk. It is just a sphere made of stars. But why is it yellow? Why is it golden? Color in astronomy is age. Blue stars are young, hot giants that live fast and die young. If there is a lot of blue in a galaxy, it means it is alive. New luminaries are being born in it right now. And yellow and red are the colors of old age. These are the colors of stars that have already lived for billions of years and are preparing to retire. IC1101 is yellow because it is old. It has almost no gas left from which new stars could be born. It is a cosmic-scale nursing home. Imagine a world where new lights never light up in the sky. A world where all stars are ancient red and yellow dwarfs, or bloated red giants. A world of eternal twilight, of a great civilization that passed its peak billions of years ago. That is exactly what this galaxy looks like from the inside. There is very little dust there. The gas needed for star formation is either already used up or heated to such temperatures that it cannot compress and turn into a star. But if she is so old and dead, how did she become so huge? After all, to grow, you need to build new stars, right? No, there is another way. The path of the warrior. Or, to be more precise, the path of the eater. Elliptical galaxies of such sizes are not born this way immediately. They become this way. They grow on the bones of their neighbors. Here we approach the first critical point of our story. We must realize the mechanics of this monstrous growth. How could an object 6 million light-years in diameter form in a universe that is only 13.8 billion years old? It seems impossible. Gravity simply wouldn't have enough time to gather so much matter into one pile peacefully. The answer lies in violence. The galaxy IC1101 is a graveyard. It is a monument to thousands of other galaxies that had the misfortune of being too close. We call this galactic cannibalism. In the early universe, galaxies were located closer to each other. Collisions were the norm, not the exception. And in the center of the Abell 2029 cluster, there was a lucky embryonic galaxy that began to attract neighbors to itself. Imagine this process. 2 spiral galaxies, beautiful, full of life, fly towards each other. They collide. But this is not a collision of two cars. This is a dance that lasts millions of years. Gravity tears apart their spiral arms, throws streams of stars into open space. Gas collides, heats up, fireworks of new stars flash. But then everything calms down. The structure is destroyed. Chaos turns into order, but it is the order of death. The spirals disappear. Two galaxies merge into one large, shapeless, elliptical blob. Now repeat this process not once, and not 10 times. Repeat it thousands of times. IC 1101 swallowed all galaxies comparable to the Milky Way and Andromeda that were nearby. It grew like a snowball rolling down a mountain, only instead of snow, there were stellar islands. Each absorption added mass to it, inflated its halo, made it bigger and bigger. She became the dominant predator in her pond. When you look at a photo of this galaxy, you see a soft golden glow. But know that every point of this glow is a star that once, perhaps, belonged to another galaxy. These are orphan stars, forcibly adopted by this giant. And now, they are doomed to circle forever in a chaotic swarm around a common center, forgetting that they were once part of a graceful spiral. But size is not just diameter, it is also mass. How much does this monster weigh? Astronomers tried to weigh IC 1101 by observing how fast the stars move on its outskirts. And the numbers they got break the brain again. Its mass is estimated at roughly 100 trillion solar masses. 100 trillion. For comparison, the mass of the Milky Way, together with all dark matter, is about 1.5 trillion. That is, this object is almost 100 times more massive than us by the most modest estimates. But there are estimates that say, if you count the entire halo of dark matter, it could be thousands of times more massive. Here it is important to pause and realize that we see only the tip of the iceberg. The visible part of the galaxy, that very golden sphere, is only the part where the density of stars is high enough for us to register them with our instruments. But such giant elliptical galaxies have a so-called diffuse halo. This is a cloud of very sparse stars that stretches far beyond the visible boundary. If we could see better in the dark, we would notice that the tentacles of this galaxy, its gravitational influence, extend even further than 6 million light-years. She holds the entire Abell cluster in fear and submission. In fact, the boundary between the galaxy itself and the cluster is erased. Where does IC 1101 end and intergalactic space begin? No one can say for sure. She simply dissolves into space, filling everything with herself. But what feeds this monster from the inside? In the center of any self-respecting large galaxy sits a supermassive black hole. In our Milky Way, it is Sagittarius A star. Its mass is 4 million suns. We think that is a lot. It is a huge hole around which our galaxy rotates. But in the center of EIC 1101 sits an object compared to which our Sagittarius A is just a grain of sand. The black hole in the heart of this giant is one of the largest ever found in the universe. Its mass is estimated in the range from 40 to 100 billion solar masses. Think about the difference. 4 million for us, and 100 billion there. If we placed this black hole in the center of the solar system, it would swallow not only the Sun and Earth. Its event horizon, the point of no return, would extend far beyond the orbit of Pluto. Light would take days just to cross the diameter of this black hole. It is this black hole, most likely, that became the reason the galaxy died. When it was active, when it devoured gas and stars on an industrial scale, it turned into a quasar. It shone so brightly that it eclipsed the light of all the trillions of stars in the galaxy. And the jets, streams of plasma that erupted from its poles, worked like giant fans. They blew the gas out of the galaxy. They heated it up and pushed it away. And gas is fuel for new stars. The black hole, having eaten its fill, simply sterilized its hostess. It killed the possibility of new life being born. It doomed the galaxy to slow aging. This is the paradox of greatness. To become the biggest, the galaxy had to sacrifice its future. She had to become a cannibal, survive thousands of collisions, grow a monstrous black hole inside herself, which eventually stopped her heart. IC11. 01 is the price of absolute power in space. Loneliness, old age, and a size that cannot be comprehended. But let's get back to the numbers, because only through comparison can you truly feel this horror. The diameter of the Milky Way is 100,000 light-years. The diameter of IC 1101 is 6 million. If you reduce the Milky Way to the size of a tennis ball, then this galaxy will be the size of a 2-story house. Imagine holding a tennis ball in your hand and standing next to a house. That is the difference. And in this house, in every room, in every corner, stars are burning. 100 trillion stars. If we lived on a planet orbiting a star inside this galaxy, our sky would look completely different. We have dark nights. We see individual stars. There, most likely, there would never be a night. The density of stars in such galaxies, especially closer to the center, is much higher than ours. The sky would be flooded with the eternal, even radiance of millions of nearby suns. It would be a world without darkness, a world of eternal light and eternal radiation. Perhaps life as we know it is impossible there, simply because the level of cosmic rays from such a density of stars would sterilize any planet. But this is not the only problem. We are now on the threshold of the second critical point. We discussed the size, we discussed the past, but there is a detail that breaks the logic of physics even more. The fact is that according to modern models of the evolution of the universe, such objects should be rare, or they shouldn't exist at all. The standard cosmological model tells us that structures in the universe grow hierarchically, from small to large. First small galaxies, then they merge into large ones. But the time that has passed since the Big Bang is barely enough to manage to assemble such a giant. IC 1101 is a challenge. She is too big, too ready, too old. She looks as if she reached this state a very long time ago. This forces scientists to ask uncomfortable questions. Maybe our models of galaxy mergers are wrong. Maybe in the early universe, processes went much faster. Or maybe we underestimate the role of dark matter, which worked like glue, assembling this monster with incredible speed. We are approaching the equator of our journey. We looked at this Leviathan from the outside. We were horrified by its size. But the most interesting part is ahead. What will happen if we try to fly through it? What will we see inside this golden fog? And most importantly, what fate awaits this object in billions of years? After all, nothing is eternal, not even such titans. In the next part, we will dive inside the Abell cluster. We will talk about how IC 1101 continues to steal matter from its neighbors even now, although it would seem she has had enough. We will discuss dark matter, which makes up 90% of the mass of this object, and without which it would simply fly apart. And we will touch upon the frightening theory that in the future the entire universe may turn into similar giant, dead islands drifting in an infinite void. This is a scenario that astrophysicists call heat death, but in the case of such galaxies, it looks particularly majestic and tragic. But for now, let's fix this image in our heads. A yellow giant, 6 million light-years, 100 trillion stars, and somewhere there, at a distance of 1 billion years, a small blue dot, our Earth. from which we look at it through the glass lenses of telescopes and try to understand how nature could create something so grandiose and frightening at the same time. So we stand before the face of this Leviathan and try to realize its scale. But what we see with our eyes, that very golden glow of trillions of stars, is a deception. It is merely the tip of the iceberg. If we had eyes capable of seeing gravity, if we could see the hidden mass of the universe, then IC 1101 would appear before us in a completely different, even more terrifying guise. The fact is that visible matter, all these stars, planets, gas, and dust, make up a negligibly small part of the true mass of this object. We are entering the territory of dark matter. To hold together 100 trillion stars, to force them to rotate and not fly apart in different directions, a colossal force of attraction is needed. Visible stars are not enough for this. Their mass simply won't be enough. If there were only stars there, this galaxy would collapse like a house of cards in the wind. But it stands. It is monolithic. This means that it is immersed in a giant, invisible ocean. Astrophysicists call this a dark matter halo. Imagine that the galaxy itself, this glowing ball 6 million light-years in diameter, is just a pit inside a huge invisible peach. The dimensions of this dark matter halo go far beyond visible light. Some calculations show that the gravitational influence of this monster can extend for tens of millions of light-years. It is no longer just a galaxy. It is a gravitational anomaly that warps space around itself so much that it works like a giant lens. Light from distant galaxies behind it bends around it, creating bizarre arcs and rings. We look at IC 1101 and see how space itself around it groans under its weight. But let's look inside the Abell 2029 cluster, of which she is the queen. It is not an empty place. The space between galaxies in this cluster is filled with gas. But this is not the cool hydrogen from which stars are born. It is superheated plasma. The temperature of this gas reaches 100 million degrees. It glows, but not in the visible range, but in the X-ray. If you looked at this cluster with X-ray eyes, you wouldn't see individual galaxies. You would see one solid, bright, blazing spot. It is this hot gas that is the curse of IC 1101. It is too hot. For a star to be born, gas must cool and compress under the influence of gravity. But here, in the center of the cluster, the energy of the particles is so high that they rush around like crazy and cannot gather in a pile. The galaxy is literally boiling in its own juices. It floats in boiling water. This explains why it is dead. It has food. It is surrounded by matter, but it cannot digest it and turn it into new stars. This is Tantalus on a cosmic scale. Water is everywhere, but it is impossible to drink. But if she cannot birth stars, she found another way to maintain her greatness. We have already talked about cannibalism, but let's break down what it looks like right now. Do you think the process is complete? No. At this very second, IC 1101 continues its meal. Astronomers see several smaller galaxies falling onto it right now. But it doesn't look like a head-on collision. It is a slow and painful death. When a small galaxy approaches this giant, it falls into tidal forces of monstrous power. Imagine being pulled by the legs with a force 1,000 times greater than by the head. You would simply be stretched into a string. The same thing happens to victim galaxies. They don't crash, they smear. First, the outer layers of stars are torn from them, forming long stellar streams similar to comet tails. These streams wind around IC 1101 like spaghetti on a fork. Layer by layer, the giant devours its victim, stripping it to the core. Eventually, the dense core of the small galaxy falls into the center to be torn apart and consumed by that very supermassive black hole we talked about. This process is called stripping, and it happens constantly. IC 1101 is not a static object. It is a constantly working meat grinder. It cleans the space around itself. That is why there are so few other large galaxies in the center of the Abell cluster. She ate them all. Only small fry remain, which are still circling at a safe distance, but their fate is also sealed. It is a matter of time. 1 billion years, 2, 10, gravity knows how to wait. But there is another mystery that haunts scientists. This is the core of the galaxy, the very, very center. Logically, there should be the highest density of stars there. They should flow there. But observations show a strange thing. The core of IC 1101 is unusually large and flat. There are fewer stars there than models predict. It's as if someone took a giant spoon and scooped out the very middle. Who could have done this? The main suspect is the same supermassive black hole, or rather, 2 black holes. There is a hypothesis that when IC 1101 absorbed another large galaxy, their central black holes met. They didn't merge immediately. They began to circle around each other, performing a deadly waltz in the center. 2 black holes, each weighing billions of suns. Their gravitational interaction worked like a gravitational slingshot. Stars that were careless enough to fly past this pair received a powerful kick and were thrown from the center of the galaxy to the outskirts. This process lasted millions of years. The binary black hole worked like a mixer, scattering stars to the sides and scouring the core. This explains why the center of the galaxy is so sparse. It is a scar from a battle of 2 titans that happened billions of years ago in the very heart of the monster. Eventually, the holes merged, creating that ultra-massive abyss that sits there now. But the traces of their struggle remained, forever burned into the structure of the galaxy. Let's now distract ourselves a little from destruction and think about life. We love to look for exoplanets. We look for Earth twins. What are the chances of finding life in IC 1101? Purely statistically, among 100 trillion stars, there must be billions of planets similar to Earth. Rocky, in the habitable zone, with liquid water. But what kind of life can arise there? As we said, there is no night there. But the problem is not only in the light. The problem is in metals. In astronomy, metals are all elements heavier than helium, carbon, oxygen, iron, everything that we consist of. These elements are produced in the interiors of stars and thrown into space during supernovae explosions. But in old elliptical galaxies, supernovae explode rarely. There is little gas, few new generations of stars. This means that the metallicity of stars there may be different. Planets there may be poor in iron, silicon, and most importantly, radiation. Due to the monstrous density of stars, the background level there can be fatal for protein life. Any atmosphere will be constantly bombarded by streams of particles from thousands of neighbors. If there is life there, it most likely hides deep underground or under a layer of ice. Or it is life based on completely different principles that we cannot imagine. Civilizations arising there would never see dark space. They might not even suspect the existence of other galaxies, because the light of their own stellar city would eclipse the universe outside. For them, universe and galaxy would be synonyms. They would be locked in a golden cage 6 million light-years in size. We are approaching the second critical point of our story. The future. What awaits this giant? We are used to everything dying. Stars go out, people die, civilizations collapse. But IC 1101 is already, in fact, dead. She produces nothing new. She only consumes. But what will happen when there is nothing left to consume? We look into the future trillions of years ahead. The Abell 2029 cluster is not eternal. Gravity continues its work. Small galaxies will fall onto the center less and less often because they simply won't remain. IC 1101 will remain in absolute solitude. She will swallow all her children. And then, the longest and saddest process in the universe will begin: fading. The stars it consists of are not eternal. Red dwarfs can live for trillions of years, but even their fuel will run out. One by one, the light bulbs in this giant house will start to burn out. The galaxy will begin to dim. The golden color will change to dull red, then to crimson, and finally to black. It will turn into a graveyard of cooled stellar remnants, white dwarfs, neutron stars, and black holes. But even then, it will not disappear. Its gravity will hold these dead remains together for an unimaginably long time. It will be a giant ghost floating in the dark, a monument to the era of stars that will stand longer than the era of stars itself. Some scientists believe that at the very end of time, when all stars go out, such galaxies will become the last islands of order in the chaos of entropy. The supermassive black hole in the center will begin to evaporate due to Hawking radiation, but this will take a Google years, a 1 with 100 zeros. But while this finale is still far away, IC 1101 serves as a reminder to us. A reminder that the universe was not created for us. It was created for monsters like this. We look at it and understand. Our Milky Way, which seems so huge and important to us, is just breakfast for such a galaxy. If our galaxy collided with IC 1101, we wouldn't even be the main course. We would just be a light snack swallowed in a couple of 100 million years. Our spiral structure would be destroyed, our sun would be thrown somewhere into a distant orbit in the halo, and we would become part of this eternal, yellow, dead light. It is scary, but it is also admirable. Nature is capable of creating structures of such a scale that cannot be comprehended and maintaining their existence for billions of years. And the fact that we, small carbon creatures, were able to find this object, measure it, weigh it, and understand its history is perhaps the greatest miracle. We cannot reach out and touch it, but we have reached it with our minds. We are approaching the finale of our story. In the third, final part, we will try to go beyond the limits of one galaxy and look at the whole picture. After all, IC 1101 is not just a mistake of nature. It is, perhaps, a prototype of what our entire universe will turn into. We will discuss the Big Crunch theory and how the merger of all galaxies into one could lead to a new Big Bang. And we will also answer the question that torments many. Can something even bigger exist? Is there a limit to the growth of galaxies? Or do monsters hide somewhere in the depths of space, beyond the horizon of visibility, compared to which even IC 1101 will seem like a dwarf? We will talk about superclusters, about the Hercules Corona Borealis Great Wall, and about how these structures are connected to our heroine. Get ready. The last part will be dedicated to the limits of the possible. We will go where astrophysics ends and pure philosophy and fear of infinity begin. Don't switch. The most grandiose is yet to come. We stand on the top of a mountain, looking at IC 1101, and it seems to us that there can be nothing more, that this is the ceiling, the limit of nature's capabilities. But the human mind is designed in such a way that it always asks, what if? Can a galaxy even bigger exist? 10 million light-years in size? 100 million? Why must this process stop? The answer to this question is frightening in its hopelessness. There is a limit, and it is set not by gravity, but by its evil twin, dark energy. Imagine that the universe is dough that is constantly rising and expanding. Gravity tries to gather raisins, the galaxies, into big piles, but the dough expands faster than the raisins can stick together. IC 1101 managed to grow to its monstrous size only because it was born in a very dense region, in the center of a cluster, where gravity defeated expansion for a while. But now the rules of the game are changing. The universe is expanding with acceleration. The space between galaxy clusters is stretching so fast that gravity can no longer pull the rope to its side. Neighboring clusters that could have fallen onto IC 1101 in the future and made it even bigger are now flying away from it. They will never meet. The doors are closing. The era of building giants is over. We live in a time when the largest structures are already built, and nature will no longer be able to create anything more grandiose. IC 1101 is a monument to a bygone era of maximum growth. This leads us to the thought that this galaxy is not just a unique object. It is a prophecy. It is a model of the future for us. Billions of years will pass. Our Milky Way will collide with Andromeda. We will merge into one large elliptical galaxy, which scientists jokingly call Milkomeda. Then we will swallow the Triangulum Galaxy and all the dwarfs around us. Our entire local group will turn into one big, boring yellow ball, similar to IC 1101, only smaller. And what will happen to the rest of the universe? Due to dark energy, all other galaxy clusters will fly beyond the event horizon. They will move away from us at a speed exceeding the speed of light. The sky will become empty. Imagine an astronomer of the distant future living in such a united supergalaxy. He points a telescope at the sky, and what does he see? Nothing. Only the stars of his own galaxy. No nebulae, no other spirals, no cosmic microwave background. All traces of the Big Bang will disappear beyond the horizon. This astronomer will think that his galaxy is the entire universe, that it is eternal, static, and surrounded by infinite eternal emptiness. He will never know that the world was once full of trillions of other galaxies. He will never know about the existence of monsters like IC 1101 because the light from them will never reach his eyes again. We are lucky. We live in the golden age of cosmology. We see the past, we see diversity, we see the structure of the cosmic web. We see these giant beacons before they have finally sailed into the darkness. IC 1101 now serves as a reminder to us of how cramped and connected the world once was. But let's return to our giant for the last time. Imagine you are on the outskirts of this galaxy. You hang in the void, and in front of you is a wall of light, 6 million light-years wide. This is a sight that cannot be encompassed by the eye. It is like standing in front of an ocean that fills the entire sky, from zenith to nadir. You feel not just small, you feel non-existent. Inside this ocean, civilizations are dying and being born right now. Perhaps Star Wars of scales we never dreamed of are going on there. Perhaps someone there built Dyson spheres around their dying stars, trying to save the last crumbs of energy. But for us, it all merges into a single, silent, golden light. Distance erases details. The tragedies and triumphs of trillions of beings turn simply into a spot on the sensor of our telescope. Is there anything bigger? Yes. Galaxies are not the limit. Galaxies gather into clusters, clusters into superclusters, and superclusters line up in the filaments of the great cosmic web. IC 1101 is the queen of the Abell cluster. But this cluster itself is just a knot on one of the threads. There are structures compared to which even this galaxy is a grain of sand. The Sloan Great Wall, the Hercules Corona Borealis Great Wall. These are objects billions of light years in size. But these are no longer single bodies. These are not whole organisms held together by the gravity of one black hole. This is the architecture of the universe. IC 1101 is the largest brick from which this building is built, the largest single stone in the foundation of creation. We are ending our journey. We flew 1 billion light years to look the monster in the face, and we saw in it not evil, but inevitability. IC 1101 is the final station of the evolution of matter. This is what gravity strives for: absolute unity, absolute mass, and absolute loneliness. Next time you look at the night sky and look for the Milky Way, remember that somewhere out there, in the constellation Virgo, in the deep darkness, the Queen sleeps. She is 60 times bigger than our home. She ate thousands of worlds, and she waits for the end of time, slowly drifting into eternity. Humans are the way the universe knows itself, and today we have known one of its limits. But the cosmos is full of opposites. If there is a place where there is too much matter, where it is compressed to the limit, it means somewhere there must be a place where there is no matter at all. A place that scares not with its size, but with its emptiness. We call such places voids, and the scariest of them is the Boötes Void, the great nothing, a sphere of darkness inside which thousands of galaxies could fit, but there is almost no one there. If we lived there, we wouldn't know that there are stars in the universe. What is hiding in this darkness? Maybe it is a place where Type 3 civilizations rule, having hidden their stars? Or is it a hole in the very fabric of reality? About this, about the loneliest and darkest place in the universe, I will tell in the next video. It is already on your screen. If the scale of the giant impressed you, then the scale of the void will make you shudder. Click and continue to explore the abyss with us. The cosmos is closer than it seems. See you